I'd like now to talk about the synthesis of epoxides. The usual reagent for synthesizing epoxides from alkenes is metachloropyrbenzoic acid, or MCPBA. That's this compound here. And the main point about MCPBA is what it does is it takes an oxygen and basically plonks it on top of a double bond. And we lose the double bond, it becomes a single bond, and we get this cyclic structure, which is the epoxide. Now, the main thing about the epoxide formation is that it is stereospecific. We start off with a transalkene, we'll end up with a trans epoxide. We start off with a cisalkene, we'll end up with a cis epoxide. And the reason for this is because we have a simultaneous reaction or a concerted process going on. So take a look at this animation, and we'll see it again. Alright, so here's your per acid right here. Just pretend that this is the aromatic ring with the chlorine on it over here. Here is your alkene, and if you look closely you'll see that the oxygen from this perbenzoic acid is going to end up being plonked straight on top of the epoxide like that. Okay, so let's see if we can do it a little slower. Alright, notice how it's a concerted process. Both bonds to the oxygen are forming at the same time. And there's our epoxide product. Alright, there's a number of ways to draw epoxides, and I just want to show you that. So here's a cis alkene, which could be drawn like this, or it can be drawn like this. And here's the epoxides that can be drawn either this way. This would be a cis epoxide here, and this would be a cis epoxide as well. Alright, let me show you this in terms of the diagram. Alright, so this one, I'll try and orient it the same way. There we go. Now in this case, the ring with the oxygen in it, this ring here, is in the plane of the screen, and then you've got these two bonds coming out here. This would be for a cis epoxide. If that were the case, these would be two methyl groups sticking out here and here where I'm putting the mouse. The other way of presenting it is to put this out here like this. So the methyl groups, there we go. So if these were two methyl groups, these methyl groups would be sticking down. These would be in the plane of the screen, and then the oxygen would be sticking outwards, and that's what I'm trying to show here. In the case of a trans, this would be a methyl group, and this would be a methyl group, and that would be it there, and the oxygen would be sticking outwards. We can put this back in the plane, and if it was trans, that would be a methyl, and that would be a methyl, and the way it would be presented would be like this: out and then in.